All right, question 451 says the hood of the automobile is supported by the strut AB, which exerts a force of about 24 pounds on the hood. Determine the moment of this force about the hinged axis Y. So we need a couple of things here. First off, we need to find the force itself in IJK. Now, this is something that you've done in previous modules. Note that point B, it may be hard to tell from this diagram, but it is at basically a point 2, 2, and 4 feet. And point A right here has a coordinate of 4, 0, 0 feet. So if you want to find F is going to be that magnitude of it times a unit vector that points from A to B. And that vector from A to B is going to be negative 2I plus 2J plus 4K feet. The magnitude of that vector, the overall distance, turns out to be root 24. I'm just going to leave it like that right now, feet. So F is going to be 24 pounds times negative 2 over root 24 I hat plus 2 over root 24 j hat plus 4 over root 24. Now, I won't lie to you, these numbers don't turn out really exact, so I'm going to leave them as root 24 for now because I think it's easier than having to always write down all these decimal places. So this is going to be negative 48 over root 24 I hat, and 4 times 24 is 96 over root 24 pounds. So that force, we like to find what it is on the y-axis. So the first thing we have to do is find a vector, the axis of interest, and you can see that that is the y-axis. So I am just going to write this as that is going to be 0I plus 1J plus 0K hat. Now we need a position vector from any point on the axis of interest to any point on the line of action of the force. So notice there's a couple of things. First off, I think the easiest thing to do is take the origin here, because it's not only is it on the y-axis, so that actually makes a nice easy point. But now what you could do then is go to any point on the line of action. So you could use ROA or ROB, where ROA is just 4I plus 0J plus 0K, and B is 2I plus 2J. Hey, we already sort of found these, so that's good. So then we have to use now the triple scalar product, where the moment of the force along the y-axis is going to be the triple scalar product of u, y, the axis of interest, with the cross product, r cross f, where this could be OA or OB. So the question becomes, which one should you use? Well, once again, they're all going to give you the same answer. What I would recommend doing is pick the one that looks like it's going to be the easiest to use. And because there's only one component here, 4I, that seems like it might be the easiest one to use. So with the triple scalar product, the top row is that axis of interest. So this is going to be 0, 1, and 0. I'm going to use ROA. So that's going to be 4, 0, and 0. And this is going to be the force, negative 48 over root 24, 48, and 96 for root 24. So the triple scalar product then is going to give you, I'm going to have a 0. And actually this will give me a 0 minus, because of the j hat, this will be the 1. And this will be 4 times 96 over root 24 minus 0. And then once again on the top, it's 0. This will be 4 times 48 over root 24 minus 0. But as I said, it doesn't matter because the whole thing just turns out to be 0. And what you end up with is minus 384 over root 24. And it's not a vector, it's a scalar quantity, pound feet, which, by the way, works out to basically negative 78.4 feet. So this just, by the way, means it's clockwise around the y-axis, which makes sense because if you look at it, the strut is pushing the hood up this way, and the hood would want to rotate basically clockwise around the y-axis, which we know clockwise is the negative direction. So that's the answer. Oh, by the way, one correction here. I should not have put a vector sign right here. I'm erasing it on the MF. Why? It is the triple scalar product is a scalar. It's not a vector. I should not have had the vector sign. It adds up to just a value. It is a scalar, not a vector. Well, that's the answer. If you have any questions, please feel free to get into contact with me. Other than that, thank you for watching and have a great day.